Hello students, this is Mr. McAllen speaking, and today I'm going to talk about how we measure angles in degrees or in radians. But I'm going to give a little bit of a history to it, as I did in class if you were in class. If not, I'm going to try to make this so that you understand it without being in class at all for today. So for the most part, we've been measuring angles um, with degrees. And, we know what a 90-degree angle is. We know what approximately like a 30-degree angle would be. But we're going to switch over to this thing called the radian system. And so a little bit of historical perspective on this. Our years are basically on a 364 day per year system. And in ancient civilizations, since they were probably farming civilizations, they knew the year was cyclical. And as such, they considered um, each day that went by as being 1 degree out of 360 because they're just a nice even number to work with to characterize um, the units or the individual increments as you go around a circle. So 1 degree would count for just a tiny amount of the circle, and 90 degrees would account to a quarter. So anyway, this system works as long as, we want mathematics to be universal, but this degree system is not really, it's kind of flawed because if you had a system where let's say that instead of 360 days in a year, you had 720 days in a year, the mathematics would be thrown off. Well, in other civilizations, they came up with this system where let's make the angle unit based upon something to do with each circle. So, for example, we know that that's the radius of a circle. They based the amount that you move in an angle to be related to the length of one radius. And that amount is known as a radian. Now, a radian, in most units, when you see radians, you see things like, 2 pi radians, or you say pi over 3 radians. But what a radian really is, and I'm going to mark it up on the circle here, is it's how far this radius would make it around the circle. For example, in any one circle, if you imagine stretching that radius out along the circle, you would see that you have 1, 2, 3, 4, 5, almost, well, actually more than 6 radii that would give you how far your angle moved. So what this basically is, as you know, there are in a circle, there are 2 pi radians in a full revolution. So the idea of what a radian is it clearly comes from um, considering the radius of the circle as a measure for how far your angle has moved along that circle. In order to answer questions using radians, the first thing that's most important is that you understand to approximate pi as 3. So, when we ask you, hey, where are you on the circle if your angle is pi over 2 radians, we don't want you to say 1.57 radians. That would be dividing 3.14 divided by 2. We want you to say, well, you're approximately located at 1.5, which would be 3 over 2 radius lengths or radians from the standard position. So that's how we want you to answer questions. So let's look at some of the problems that we would maybe ask people to do using radians. For example, I'm going to zoom in so you can see this. Here's a, oops, here is a circle, or here's a number on these questions 1 through 4. They're asking you to draw a unit circle or draw just a circle and show where pi over 4 radians would be. So if you were to do this, you would just, draw yourself a circle, mark where 0 radians would be, and consider that this is going to be pi over 4 is approximately 3 over 4 radians. So you're not quite, if this is the length of the radius, you're not quite at the, you're not quite a full radius away. So I'm going to just mark here like a full radius would be approximately this location. So your angle is just a little bit less. And you would say on the circle that this is 3/4 of a radian, or pi over 4 radians. If they said, where are you when you're at pi radians, you would know that's 3 radius lengths. So that would put you, this is 1 radius, 2 radius, 3 radii. That'd put you about the 180-degree mark, but we're going to say that's at pi radians. So when you work on these problems tomorrow, we really want you to think in terms of pi as being 3, and then when they ask you, what the angle amount, where the angle amount would put you, think of these in terms of radius lengths around any circle that you draw. If we look over here at number 5, I'm going to use a circle to help me out with it. But if it says, where are you when you're at 3 pi over 4 radians, you would say, well, that's like 9 over 4. That's about 2 and 2.25 radiuses away. So I know when I go through one radius, another radius, that's 2. I'm probably around here at this point. So I'd mark my circle to be like that's point C, or question C. That would be 3 pi over 4 radians. So that's the type of work we want you to do. And when you look at this next question, if they ask you, where is point A? We want you to say that that's at approximately, if that's a radius, we want you to say that's approximately at 1 radian. So there are a bunch of questions that ask you to draw and think in terms of radians. And we'd like you to consider the true definition of a radian to be what one radius length would be along any circle. No matter how small, it could be teeny tiny. So this radius would still put you for 1 radian at this point. Or if the circle is really, really big, here's the radius. That radius would put you at about the same position. So it's more of a universal angle measurement. It doesn't matter how big your circle is. A radian is a radian. It tells you how many radii you have moved along the circumference of the circle that you're working with. So hopefully this has helped you understand that. And, here we have some other questions. Let's say that just as one more for you to do, I'd like you to consider where, let's say for part E, where E would be if this were, that doesn't look like a very good circle, but let me draw a circle for you. Let's try to make it look like a circle. So there's my circle. So where would you be at 11 pi over 4 radians? So I want you to think of pi as being approximately equal to 3. And I'm going to pause it. You might be thinking about the answer right now, but I'm going to pause it. I'm going to show what the radius of the circle is and draw the y-axis. And I want you to locate on the circle where that radian amount would be. Okay, well, we're back. And so here I took 11 pi over 4. I thought of pi as being approximately 3, so I got 33 over 4 radians, which is about 8 1/4. So what this means is I went 8 radius lengths. So here's my first radius length, here's my second one, here's my third, fourth, fifth, sixth, seventh, eighth would be over here. That'd be about my 8th radius length, and I'd be a little bit beyond it. So if I said somewhere in quadrant 2, that would exist, that would be 11 pi over 4 as far as my angle. Then I'd say that you have the general idea of how to work with radians. So tomorrow in class, we're going to practice this quite a bit. I hope this lesson or this video was instructional to you. And I'm going to have some questions on the forum to ask you to do just a few basic computations or questions to see if you comprehended the lesson today.